everyone, मेरा नाम अवनी है. Welcome to my YouTube channel. We are covering database management system as a subject, and today we are going to cover unit 7, which is transaction processing. In this unit, we will be covering the following topics like what is transaction, what are the asset properties of transaction, transaction state diagram. We will understand what is schedule, two-phase commit protocol, database recovery, concurrency, and deadlock. So without wasting any more further time, we will start with our first topic, what is transaction. So ask yourself, transaction का मतलब क्या होता है? For example, एक अकाउंट से दूसरे अकाउंट में अगर हम पैसे ट्रांसफर कर रहे हैं तो उसे हम ट्रांजैक्शन कहेंगे, राइट? इसको अभी थोड़ा टेक्निकली समझते हैं. A transaction is a sequence of operations performed as a single logical unit of work. A transaction is a single logical unit of work that contain one or more SQL statements. Let's take an example that A account से आपको 50 rupees transfer करने हैं in the account B. All these instructions, they will work as a single logical unit. Let's see how. First instruction है read A. ये instruction read करेगा that account A में कितने पैसे हैं. Let's say 100 rupees है. Then 100 rupees में से वो 50 को minus करेगा. So that becomes 50. Write A. Account A की state को update करेंगे हम as 50. Then B के अकाउंट में कितने पैसे हैं वो भी रीड करेगा. Let's say B के अकाउंट में है 200. Then जितने पैसे हैं उसमें प्लस 50 हो जाएंगे. So 200 plus 50 will be 250 and वो हम अपडेट करेंगे B के अकाउंट में. That will become 250. So what we understood, A के अकाउंट में finally 50 होंगे and B के अकाउंट में finally 250 होंगे. Right? So this entire operation we call it as a transaction. This is called as a single logical unit, or also we can call it as transaction. Now let's understand asset properties of transaction. Asset does not literally mean asset. ये एक abbreviation है. A का मतलब है atomicity, C का मतलब है consistency, I का मतलब है isolation, and D का मतलब है durability. Let's see them one by one. Atomicity is either the transaction execute 0% or 100%. मतलब transaction या तो complete होगा या तो नहीं होगा. Consistency means database must remain in the consistent state after any transaction. The state has to be same. अगर A के account में 100 है and B के account में 200 है, so even after any transaction occurred, पहले भी इन दोनों का total 300 था and बाद में भी transaction के बाद में भी 300 ही total होगा. Even if this becomes 50 and this becomes 250, still the total will be 300 only. That is consistency. Isolation means intermediate transaction results must be hidden from any other concurrently executed transactions. And durability means once a transaction is completed successfully, the changes it has made into the database, that should be permanent. So let's understand atomicity more in detail first. This property states that transaction must be treated as an atomic unit. That is either all its operation are executed or none. Like I said, या तो fully complete होता है transaction या तो failure होता है. बीच का कोई state नहीं होता है. So which is 0% or 100%. Let's take an example. Consider transaction to transfer rupees 50 from account A to account B. In this transaction, if 50 rupees deducted from account A must be added to account B. Let's understand this by an example. So we will read the account A, how much money is there in the account A. We will minus 50 rupees from A's account and we will update the A's account. Till here, if the transaction fails, it's called as failure only because it has not been added to the account B. The moment it gets added into the account B and the B's account status is also updated, then we call the transaction is 100%, otherwise 0%. At this state also, if it fails, we will roll back the money back into the account A. This is called as atomicity. Now let's understand consistency. A database must remain in a consistent state after any transaction. If the database was in a consistent state before the execution of transaction, then it must remain consistent after the execution also, right? In our example, where the total of A and B must remain same before the execution of the transaction and after the execution of transaction. Let's say if account A has 500 rupees, B has 500 rupees. दोनों का total कितना हो जाएगा? 1000 rupees. So if we see over here, there is 500. 500 minus 50 will be 450 and so A's account is updated as 450, it will read B's account, which is 500, B plus 50, which means 500 plus 50 will become 550. So 450 plus 550 is still same 1000. So this is a consistent state before the execution also and after the execution also. I hope this is clear. Atomicity का मतलब क्या है, consistency का मतलब क्या है, दोनों में difference क्या है. Let's not get confused in both of them. Now third है isolation. So the changes occurring in a particular transaction which should not be visible to any other transaction until it has been committed. Committed का मतलब होता है completed. Okay. Intermediate transaction results must be hidden from any other concurrently executed transactions. So in our example, once our transaction starts from step 1, its result should not be accessed by any other transaction until the last step is completed. So if here the transaction has been started, so in between no other transaction should get access that what is the status of this transaction. Until all the steps are completed, then it can be accessed by any other transaction which is happening simultaneously. This is called as isolation property. The next one is durability. So durability का मतलब क्या है? After transaction completes successfully, the changes it has made to the database has to be permanent. Even if कोई system failure हो जाए, but it has to be permanent. Once a transaction is completed up to the last step, which is the final step, its result must be stored permanently. It should not be removed even if the system fails or anything happens. Once the last step is completed, जो ये state था and this state has to have a consistent state and this has to be updated in the database permanently. Even if system failure होता है, अगर यहाँ तक execute हो गया, so ये final step भी execute हमें करना ही पड़ेगा. That is what is called as durability. These were 4 properties of transaction. Very important: atomicity, consistency, isolation, durability. अगर हम इसको sum it up कर ले, तो atomicity का मतलब होगा या तो आपका transaction complete होगा fully या तो fail होगा, बीच में कोई state नहीं होगा. Consistency का मतलब अगर हम समझे, जो पहले before the transaction जो total है दोनों account का, after the transaction completes also वही exact same total होना चाहिए, that is consistency. Isolation, whenever the transaction is getting executed, in between कोई और concurrent transaction अगर occur हो रहा है, तो that transaction cannot access this transaction, right? That is called as isolation. Durability का मतलब होगा that once the transaction has been completed, then आपका database permanently update हो जाना चाहिए. That is durability. Start with the next topic, which is transaction state diagram, or we can call it as state transition diagram 2. So first stage is always the active stage. This is the initial state. The transaction stays in this state while it's executing. Now there are 2 possibilities. Let's understand the first possibility, which is partially committed. When a transaction executes its final operation, it is said to be in partially committed state. The transaction enters in this state after a successful completion of the transaction, and we cannot abort or roll back the committed transaction. From partially committed state, it will go to the committed stage and then it will end the transaction. Now, there is also a possibility that from the partially committed stage, if the transaction fails for some reason, it will go to a failure stage. Or from the starting of the transaction only, the second possibility is of the failure, that it discovers that the normal execution can no longer proceed. Once a transaction cannot be completed, any changes that it's made must be undone, or we can have it roll it back. So then it will enter the abort stage. The state after the transaction has been rolled back and the database has been restored to its prior state of the transaction, which was before the transaction. Let's understand this more by an example, that it will read the account A equals A minus 50, and it will write the A. If at this stage the transaction gets failed, it realizes it no longer can be executed. So at this stage, it will go to the abort stage, which means whatever was the initial state of account A, that has to be maintained. This step needs to be rolled back. If it gets completed, it will go to the account B, B equals to B plus 50. This is partially committed stage. At this point, once it writes into the B, this is the stage where it's called as committed stage. So I hope this is clear. First, it is in the active stage. 2 possibilities है, partially committed या तो failure. From partially committed, it goes to the committed stage and ends the transaction. From failure, it goes to the aborted stage where it will roll back and it will end the transaction. There is also a possibility that in the partially committed stage, still the transaction can be failed. Again, everything will be rolled back. So I hope this diagram is clear. Let's understand each state more in detail. About the first one, active state. This is the initial state. We know that the transaction stays in this state while it is executing. Then comes the partially committed state. When a transaction executes its final operation or instruction, it is said to be partially committed state. The failure stage, the fail stage, discovers that normal execution can no longer proceed for any given reasons or for any given mishaps. Once a transaction cannot be completed, any changes which is made, it must be undone by rolling it back. What is a committed stage? The transaction enters in this state after a successful completion of the transaction, which means after committing the transaction. We cannot abort or we cannot roll back if we have entered the committed transaction state. Aborted means the state after the transaction has been rolled back and the database has been restored to its prior state, which was the start of the transaction. Let's move to the next topic, which is schedule. एक schedule का मतलब क्या होता है? If you just understand the term, something in a proper sequence. So if there are 2, 3 multiple transactions, let's say T1, T2 and T3, the 3 transaction has to be executed if we align them in a proper schedule, that this will get executed first, this is second, this is third. So this will be called as a schedule. This was just an overview. Let's understand this more in a detail. A schedule is a process of grouping the transactions into one and executing them in a predefined order. Like I said, predefined sequence. A schedule is the chronological sequential order in which instructions are executed in a system. A schedule is required in the database because when some transaction execute in the parallel, when I say parallel, that T1 is getting executed some steps, at the same time T2 is also executing some steps. So this is called as parallel transaction. They may affect the result of the transaction. Means if one transaction is updating the values like this one, which the other transaction is also accessing, then the order of these two transactions will change the result of another transaction. Hence, the schedule is created to execute the transactions. Let's understand this by an example. There are 2 transactions, T1 and T2. T1 अगर पहले execute हो रहा है and T2 बाद में execute हो रहा है, this is called as scheduled transaction. How will this scheduled transaction will actually take place? Let's understand this over here by give an example that A and B दोनों की value 1000 है. तो पहले ये execute होगा. तो read A, which means it will read 1000 rupees in the account A. A equals 1000 minus 50, which will become 950. Then it will read B's account, which is also 1000. Then it will do 1000 plus 50, so it will write 1050 and commit. So now this has got updated. Now it will read again A's value, now which has become 950. It will create a temp variable 950 multiplied by 0.1, which will give you 95. And then the operation is A minus temp. 950 minus 95, it will become 855. Then it will read the B's value. B की value क्या हुई थी इस transaction में? 1050. So B equals to 1050 plus 95. Write and it will give you 1145 rupees. And then it will commit. So now do you understand why is it more important? अगर ये दोनों साथ में execute हो रहे होते, so both would have read 1000 as the initial state. However, if this transaction is getting executed next, it is reading the updated state, which is 950. It could be vice versa also, कि पहले हम ये वाला transaction execute कर रहे हैं, फिर ये वाला execute कर रहे हैं. Again, it will go in a sequence. This will get executed first and this will get executed next. This was the example of scheduling. Now let's understand what is a serial schedule, which is one of the type of scheduling. A serial schedule is a schedule in which no transaction starts until the running transaction has ended. A serial schedule is a schedule in which one transaction is been executed completely before starting the another transaction. Transactions are executed one after the other. We have seen that just now. This type of schedule is called a serial schedule, as transactions are executed in a serial manner, which means one after the other. T1 will get executed first, then T2, and then T3. This is called as serial schedule. There is also another type which is called as parallel schedule, in which T1, T2, T3, if all three or any of two transactions also are getting simultaneously executed, these are called as parallel transaction. We have seen already this example that if T1 gets executed first and then it goes to T2, T1 to T2, this is a serial schedule, or T2 gets executed first, then T1, even this is a serial schedule. Non-serial schedule that interleave the execution of different transactions, which means second transaction has started before the first one could end, and execution can switch between the transactions back and forth. It contains many possible order in which the system can execute the individual operations of the transactions. इसका मतलब है the parallel one which I was talking about, it is also called as non-serial schedule, in which T1 ने कुछ step execute की and at the same time T2 start हो गया, T1 की कुछ steps बाकी थी, then T1 execute हो रहा है, then T2 की बाकी की steps execute हो रही है. So like this it can go back and forth. This is called as non-serial schedule. Let's understand this more by an example. Schedule S, T1 and T2, there are two transactions. It will do the first step, it will read A minus 50, write A, and it will pause over here and go to T2, where it will read A temp A multiplied by 0.1, the entire operation to write A. After this, it will again go back to T1, execute the rest of the steps, and then again go to T2, execute the rest of the steps over here. Or vice versa, we can also understand that this will get executed first, then this will go over here, then this will go over here, this step, and then over here. So back and forth, it is moving from T2 to T1, then again T2, and then T1. This is an example of non-serial schedule, or we can also call as interleave schedule or a parallel schedule. Third type is equivalent schedule. If two schedules produce the same result after the execution, they are said to be equivalent schedule. They may yield the same result for some value and different result for another set of value. That is why this equivalence is not generally considered a significant. Let's see the example. So there is a schedule 1 and schedule 2. A and B both have the same value, 1000. This is non-serial and this is serial schedule. If you see that, T1 is getting executed first and T2 is getting executed next. A task for you is to perform all the steps in the schedule given over here and see what is the final state of A and B. Both the schedules are equivalent. In both the schedule, if the sum of A plus B is preserved. So the sum of A plus B, which is 2000, if that is same by the end of the schedule or by the end of this schedule, then it is considered as equivalent schedule. So your task is to check that and let me know in the comments if they are equivalent or not. Let's understand the next topic is serializability. A schedule is serializable if it is equivalent to serial schedule, which means in serial schedules only one transaction is allowed to execute at a time and no concurrency is allowed. Whereas in serializable schedules, multiple transactions can execute simultaneously, that is concurrency is allowed. Types of serializability is conflict and view serializability, which we will see further. But पहले इसका मतलब समझ लेते हैं that अगर आपका schedule in a sequence है T1, T2, then T3, then it is a serial schedule, which means इसको serialize करने की ज़रूरत नहीं है. It cannot be serialized any further. But if any transaction is there in the parallel state like this, so then this needs to be serializable. So concurrency is allowed over here because we want to convert this into the serial schedule. So this is serializable. The two types, which are conflict serializability and view serializability. Let's understand them one by one. So before going to these examples, let's establish few things that there are three conflict pairs. Okay, ये आपको याद रखने हैं. So first pair is read to write. Second pair is write to read, and third pair is write to write. Read to read is not a conflict pair. These three are considered to be as conflict pairs, which you need to remember. Read to write is one, and from write state It can go to read state also and it can go to write state also. Now let's see this example that Li and Lj are the two instructions of the transactions with Ti and Tj transactions respectively. So in the first one it is reading Q and over here also it is reading Q, which means read is not a pair, so they don't conflict. Second one, read Q and in this next one it is write. So read and write is a pair, we know that, so they conflict. Next one, write and read. Write and read is a pair, yes, so they conflict. Over here, write and write. So both again conflict because write and write is also a conflict pair. Conflict serializability means if a given schedule can be converted into a serial schedule by swapping its non-conflicting operation, then it is called as conflict serializable schedule, which means आपके पास कोई non-serial schedule है which you can convert into a serial schedule by swapping या by interchanging the non-conflicting operations. Let's see over here, there is a transaction 1 and transaction 2. This over here is reading A and A minus 50 and write A. Then this operation is actually getting executed, then this operation and then this operation. Can we make it? Can we convert it into a serial schedule? Yes, we can. We can either go from T1 to T2 or we could also do T2 to T1. How could we do that? Either we move this instruction up, so then T1 will get executed first and then T2, or we could move this instruction down, even that will work. So over here we have done T1 getting executed first and T2 getting executed next. So we have swapped the non-conflicting values over here. So we have swapped the non-conflicting operations over here. How? Because there is a read operation here, read operation over here, which are non-conflicting, which we are trying to swap. Either this can go up or this can come down. Let's see an example of a schedule that is non-conflict serializable. Over here it's reading and writing over here in the transaction 2. So from here we are unable to swap instruction in the above schedule to obtain either the serial schedule from T1 to T2 or from T2 to T1 because there are no non-conflicting operations over here. These are incomplete operations over here. So that's why this was the schedule that is non-conflict serializable. Second type is view serializability. अब इसका मतलब क्या होगा? Let's say S1 and S2, there are two schedules with the same set of transactions. S1 and S2 are view equivalent if following three conditions are satisfied. What are the conditions? That the initial read is same, updated read is same, and final write is same. If the schedule is view equivalent to its serial schedule, then the given schedule is said to be view serializable. Let's understand this by an example. If in a schedule S1, transaction Ti reads the initial value of Q, then in schedule S2 also transaction Ti must read the initial value of Q only. अब ये यहाँ पे तीन schedule है S1, S3 and S2. So above two schedule S1 and S3 को compare करते are not view equivalent. क्यों? Because the initial read operation in S1, which is read A, is done by T1 and in S3 it is done by T2. So क्या ये view equivalent है? No. Above two schedule S1 and S2 are view equivalent. क्यों? क्योंकि S1 में भी read A is done by T1 and S2 also the read A is done by T1 only. We can say S1 and S2 are view equivalent or view serializable, which means first condition satisfied, initial read. The next condition, which is updated read. There are three schedule S1, S3, S2. Again, S1 and S3 are not view equal. Why? Because in S1, T3 is reading A and that is updated by T2. But in S3, which is this schedule, T3 is reading A, which is okay, but it is updated by T1. इसके बाद ये इधर जा रहा है instead of here. Now let's see the S1 and S2. Again over here T3 is reading A, which is updated by T2. Over here also it is T3, which is reading A getting updated by T2. So we can say that above two schedules, which is S1 and S2, are view equal in this condition also. Next condition, which is final write condition. Above two schedule S1 and S3 again are not view equal because final write operation in S1 is done by T3. However, in the final write operation in the S3 is done by T1. But however, S1 और S2 का अगर हम compare करते हैं, so final write operation is done by T3. S2 may be final write operation is done by T3. So we can say that this condition also is satisfied. So S1 and S2 are view equivalent, which means view serializable. Let's see this example. If a schedule is view equivalent to its serial schedule, then the given schedule is said to be view serializable. Like I said, over here, this is a non-serial schedule. T1 is there and T2 is there. How can we make it view serializable? S2 is the serial schedule of S1. S2 is the serial schedule of S1. If we can prove that they are view equivalent, then we can say that given schedule S1 is view serializable. Simple hai, we convert or we put the steps over here and we put the steps over here. So this will get executed first and T2 will get executed next, which makes it as serial schedule over here. So this means this is view serializable. But अब इसको तीनों condition में satisfy हो रहा है नहीं हो रहा है, that we will check now. Okay, first condition is initial read. So in schedule S1 over here, T1 reads the first data. T1 reads the first data. In S2 also, T1 reads the first data item X. Correct. In schedule S1, transaction T1 first reads the data item Y. In S2 also, the first read operation on Y is performed by T1, which means over here and over here also. The initial read condition is satisfied for both schedules. Second condition, which is updated read. In schedule S1, transaction T2 reads the value of X, which means reads A, written by T1. In S2 also, the same transaction T2 reads the X after it is written by T1. The updated read condition also satisfied both the schedules. Let's see the next one, final write. In schedule S1, the final write operation on X is done by transaction T2. In S2 also, the transaction T2 performs the final write on X. The final write condition is also satisfied for both the schedules, which means first condition initial read satisfied, second condition updated read satisfied, third condition final write satisfied. What does that say? This S2 is the serial schedule of S1, which means they are view serializable. Since all three conditions that checks whether two schedules are view equivalent are satisfied in this example, which means S1 and S2 are view equivalent. Also, as we know that schedule S2 is the serial schedule of S1, thus we can say that the schedule S1 is view serializable schedule. Let's understand our next topic, which is two-phase commit protocol. Two-phase commit protocol ensures that all participants perform the same action, either to commit or roll back a transaction. जिसका मतलब है जितने भी लोग participative हैं in the transaction, they all have to follow a same action only. फिर चाहे वो roll back हो या commit हो. It is designed to ensure that either all the databases are updated or none of them, so that the database remain in sync, which is very, very important. In two-phase commit protocol, there is one node which act as a coordinator, जिसको हम ये भी कह सकते हैं controlling site, जिसको let's call it as a boss, who will basically give the instruction to all the participating nodes, which are called as cohorts or participant or slave. So basically the employees of this boss which will follow the instruction. Term इसको हम दे देते हैं coordinator, boss को हम कहेंगे coordinator, and cohorts मतलब employees या फिर slaves जो हमने यहाँ पे कहा है. Each individual node except the coordinator or the participant, and as the name suggests, the two-phase commit protocol involves two phases. क्या two phases है? The first phase is called as commit request phase, or we can call it as prepare phase also. And the second one is commit or abort phase. तो पहले हम prepare करेंगे commit के लिए, and next phase में या तो commit होगा या abort होगा. Let's understand this more with an example. So this is the boss in the middle. If you see, we can call it as a coordinator. ये सारे participants हैं. We can call them as a slaves or participants. So what will coordinator do? It will send a request asking if they are ready to commit or not. This will happen in the preparation phase. Then the participants send a reply whether they are ready to commit or not. This also happens in the preparation phase. Okay. Then coordinator will inform to do the commit, which will happen in the commit phase. And then participants will perform the commit action, and then they will send an acknowledge message to inform whether the commit has been done or not done. This also happens in the commit phase. So 4 actions are getting performed. In the preparation phase, 2 actions, and the commit phase, 2 actions. Preparation phase, coordinator is giving an instruction or sending a request to prepare for commit. Once participants are prepared, they send the message back that they are ready. In the commit phase, the coordinator will send the message to start the commit action, and once it is done, all the participants will send the message informing it's done. Let's understand this commit request phase, which is also called as obtaining decision. After each slave has locally completed its transaction, it sends a done message to the controlling side, which means the coordinator. When the controlling side has received done message from all slaves, it sends a prepare to commit message to the slaves. The slaves vote on whether they still want to commit or not. That's the second transaction which is happening. If a slave wants to commit, it will send a ready message. If slave that does not want to commit sends a not ready message. This may happen when slave has conflicting concurrent transactions or there is a timeout. So this will happen in those kind of scenarios. The commit phase, which means the performing decision phase, after controlling side, which is the coordinator that has received the ready message from all the slaves, the controlling side sends a global commit, which means अब सबको commit perform करना है, which will be sent to all the slaves. The slaves commit the transaction and then send an acknowledgement, which means commit acknowledge message to controlling side. When the controlling side receives the commit acknowledge message from all the slaves, it considers that transaction is now committed, which means it's completed. Similarly, if after the controlling side has received the first message, which is not ready message from any slave, the controlling side sends a global abort message even if one participant has sent a not ready message. The slaves abort the transaction and send a abort acknowledgement message to the controlling side, which is the coordinator. And when the controlling side receives the abort acknowledgement message from all the slaves, it will consider the transaction has been aborted and not completed. So I hope this two-phase commit protocol is clear. If any doubts, you can mention in the comments. Let's move to the next topic, which is database recovery. अब database recovery कौन से cases में होगी? Just take a moment and सोचो. In the cases जहाँ पे by chance database failure हो गया, power off हो गया, कोई problem हो गई and हमारा data lost हो गया, in those cases हमें वो data recover करना पड़ेगा, right? In such cases database recovery is required. So there are many situations in which transaction may not reach to a commit or the abort point. क्या situations हो सकती है? Operating system crash हो गया, database crash हो गया, system might lose the power failure हो गया, disk may fail और other hardware failure हो गया या human error हो गया. So in any of the above situation, data in the database may become inconsistent or lost. For example, if a transaction has completed 30 out of 40 write instructions to the database, so when the database crashes, the database may be in inconsistent state as only some part of the transaction work has been completed. कुछ ही instruction logged हुई है. So database recovery is the process of restoring the database and the data to a consistent state. This may include restoring the lost data up to the point of the event. Example, system crash, जिसका मतलब है जहाँ पे system crash हुआ तब तक जितनी भी instructions या operations perform हुए वो सारा data restore करना पड़ेगा. This process is called as database recovery. अब इसमें कुछ types होते हैं. So the first one is log based recovery method. A log is a sequence of the log records which maintains the information about updated activities on the database. जो भी एक्टिविटीज परफॉर्म हो रही है वो उस लॉग में जा रही है. जैसे आप अपने कॉल लॉग्स चेक करते हो, जितने भी कॉल आ रहे हैं, जा रहे हैं, मिस कॉल हो रहे हैं, वो सारे कॉल लॉग में आपको दिख जाते हैं. सिमिलर टाइप का लॉग यहाँ भी होता है. A log is kept on a stable storage which is, for an example, like an HDD. Log contains all these details: start of the transaction, transaction ID, record ID, type of the operation, चाहे वो insert है, update है या delete है, old value क्या थी transaction से पहले, and new value क्या हुई transaction के बाद, end of the transaction, that is committed or aborted, वो state. When transaction TI starts, let's take an example. It registered itself by writing a record TI start. वो हमारा first log add हो गया. Before TI executes the write operation, a log record TI x v1 v2 is written. अब इसका मतलब क्या है? Let's understand. v1 is the value of x before the write old value. मतलब write x करने के पहले old value क्या थी? And v2 will be write x करने के बाद new value क्या है? वो. When TI finishes its last statement, the log record TI commit will be written. Undo of a log record will be TI x v1 v2, which will write the old value v1 to x. Redo of a log record TI x v1 v2 again will write the new value v2 to x. The types of log-based recovery method will be immediate database modification or deferred database modification. अब लॉग बेस्ड रिकवरी मेथड तो समझ आ गया. अब इसके दोनों टाइप समझ लेते हैं. Immediate database modification means the update or the changes to the database are applied immediately as they occur without waiting to reach to the commit point. कमिट होने से पहले जो भी चेंजेस होते जा रहे हैं वो उसको immediately अपडेट डेटाबेस को करता जाएगा. Deferred database modification, the updates or the changes to the database are deferred, which means are postponed until the transaction commits. लास्ट स्टेट तक वो वेट करेगा, उसके बाद वो डेटाबेस में चेंजेस करेगा. अंडरस्टैंड दिस थ्रू एन एग्जांपल. जो लेफ्ट साइड है वो इमीडिएट है, जो राइट साइड है वो डिफर्ड है. ट्रांजैक्शन T1 इज देयर, ट्रांजैक्शन T2 इज देयर. T1 में इट रीड्स द अकाउंट A माइनस 100 हो रहा है, राइट A, रीड B प्लस 100 हो रहा है, एंड राइट B एंड देन कमिट. ओवर हियर T2 में एक्शन इज गेटिंग परफॉर्म्ड ऑन अकाउंट C. पहले इमीडिएट देखते हैं. A equals to 500, B equals to 600, C equals to 700. ये हमारी initial values हैं. So T1 will start, which means the transaction 1 will start. इसको हम कैसे लिखेंगे? T1, we are working on currently account A. 500, which is the initial value. 400, जो ये A minus 100 के बाद हो जाएगी. 500 minus 100 will be 400. Then this action will get performed. T1, B is getting read. 600, which is the initial value, B plus 100 will be 700, that will be the new value which will get updated. So then in there the database status will be A equals to 400, B equals to 700, C equals to 700, which are the new values. Immediate database has been modified. Then if we combine both the T1 and T2 operation, so we will say this part exactly the same as it is, and when T2 starts, T2C is the account, 700 is the initial state, 500 is the later state because C minus 200 हमने यहाँ पे किया है. Then we write the C and comment. So over here, what is the final status? A is 400, B is 700, and C is 500. Now let's see on the right side. Deferred database modification. Over here also, A account, B account, C account has the same amount. T1 starts exactly same as it is, T1 A, and 400. We are directly putting the final state. We are not putting the old state over here. T1 will be B 700. However, the database is still not updated because final commit abhi tak hua nahi hai. Then if we combine both of them, T1 starts, again same operations over here, 400, 700, T1 gets commit, then T2 starts, T2 C 500, which is the final state, again T2 commit, and now when the final commit has happened, now the database will get updated. A is 400, B is 700, C is 500, which is exactly same as the immediate database modification and the deferred database modification. So final result दोनों का same ही होगा, बस immediate database modification में database will keep on getting updated instantly and deferred में final step के बाद में होगा. Now let's see the differences point wise, that the updates or the changes to the database are applied immediately as they occur without waiting to reach to the commit point. And over here it is exactly opposite. It is postponed until the transaction gets commit. If transaction is not committed, then we need to do undo operation and restart the transaction again. If transaction is not committed, then no need to do undo operation. We can directly just restart the transaction. क्यों undo नहीं करना? क्योंकि update हुआ ही नहीं था. If transaction is committed, then we need to redo the updates of the transaction. Because यहाँ पे already update होता जा रहा था, यहाँ पे update end में होने वाला है. So that's why the redo step is over here. Undo and redo, both operations are performed in the immediate database modification. Over here, only redo operation is performed. Now, what are the problems which occur with deferred and immediate updates, which is also called as checkpoint? Let's understand that. Searching the entire log becomes time consuming. Yes. Immediate database modification, and when the transaction fail, the log file is used to undo the updates of the transaction. ये immediate database modification में होगा undo. Deferred database modification में क्या होगा? Redo. To reduce the searching time of entire log, we can use something called as checkpoint. Now, checkpoint क्या है? It is a point which specifies that any operation executed before it are done. Let's understand, maybe this is the checkpoint. So, इस checkpoint के पहले कोई भी transactions which are done and stored safely, at this point all the buffers are forcefully returned to the secondary storage database. Everything is getting stored at the secondary storage database. Checkpoints are scheduled at predetermined time intervals. It is used to limit the size of the transaction log file and amount of searching. Let's see that with an example over here. So how the checkpoint will work when the failure has occurred? So this line is basically for the time. This is the checkpoint and this is the failure. At failure point, ignore the transaction T1. Why? Because it has already been committed before the checkpoint. Before the checkpoint time, it has already been committed, so we don't need to look at that. Redo the transaction T2 and T3 as they are active after the checkpoint and are committed before the failure. Before the failure has occurred, it has been committed and they are still active at the checkpoint. So we need to redo them. Undo the transaction T4 as it is active after the checkpoint and has not committed. It has been not committed after the failure also, so we need to undo it. This transaction will not be completed. So that's why with the checkpoint time, it becomes very easy to track these transactions and do the operations of undo and redo. So I'll give you an exercise. This is the graph. Okay, just take a picture of it. The exercise is give the name of the transaction which has been committed before the checkpoint. Now over here, if you see, there are two checkpoints. You can call it as checkpoint 1, checkpoint 2. Give the name of transaction which will perform the redo operation and give the name of the transaction which will perform undo operations. That is your exercise. Please put it in the comment below. Now let's understand what is page table structure. This is usually the topic of operating system, but we need to understand this more further in database also. The database is partitioned into the fixed length blocks. एक fixed length blocks में database होता है, ये हमने पहले भी समझा था, and it is referred to as pages. Each block is referred to as a page. Page table has n entries, which means the number of entries, and each entry contain pointer to a page on the disk. This is the disk and contains the pointer, which means the address of the data on the disk. So these are the number of pages on the disk. These are the addresses of the data point where it is pointing on the disk. Now let's understand the next topic, which is shadow paging technique. Shadow paging is an alternative to log based recovery. This scheme is useful if transactions execute serially. एक sequence में अगर execute हो रहे हैं, serially execute हो रहे हैं, only then it is useful. It maintains two page tables during the lifetime of the transaction. Current page table and shadow page table. Now shadow page table is stored on non-volatile storage. When a transaction starts, both the page tables are identical. दोनों exactly same होंगे because shadow is also very similar exactly. Only the current page table is updated for data item accesses. जो current page है वो update होता जाएगा, change होता जाएगा according to the transaction. shadow page table is never modified during the execution of the transaction. So this is my current page. Behind this is my shadow page. Over here, the database will keep on getting updated according to the transaction. However, the shadow page will not get updated until the transaction is completed. Let's see this with an example. Page 1, page 2, page 3, page 4, page 5 is written over here, which means these are nothing but the blocks in the database. So this is my current page table. This is my shadow page table. So whenever any page is updated, first time a copy of this page is made onto an unused page. Which means if page 2 is updated, the copy of it is maintained on an unused page. The current page table is then made to point to the copy, which is pointing over here. The update is performed on the copy. So, two pages, page 2 and page 5 are affected by the transaction and copied to new physical pages as we see over here. The current page table points to these new pages. The shadow page table continues to point to old pages only, which are not changed by the transaction. So this table and pages are used for undoing the transaction if required. Undo agar required hoga, then this table will be used in such scenarios. So when the transaction starts, both the page tables are identical. We already know that. The shadow page table is never changed over the duration of the transaction. The current page table will be changed when a transaction performs a write operation. All input and output operation use the current page table. Shadow page table को touch भी नहीं करेंगे. Whenever any page is about to be written for the first time, उसकी copy बन जाएगी. A copy of this page is made onto an unused page. The current page table is then made to point to that copy. The update is performed on the copy. When the transaction gets complete, all the modifications which are done by transaction, which are present in the current page table, then will get transferred to the shadow page table. But remember, after the transaction has been completed, never during the transaction. In case when the transaction fails, the shadow page table are transferred to the current table. So understand, agar commit ho gaya, then current page table will be transferred to shadow table. However, agar fail or abort ho gaya, then from shadow table it will get transferred to current page table. Let's understand the next topic, which is concurrency. Concurrency is the ability of the database to allow multiple, which means more than one user, to access the data at the same time. Three problems which can occur due to concurrency. First, lost update problem, dirty read problem, incorrect retrieval problem. ये problems को one by one हम detail में समझेंगे. But let's understand concurrency first. अगर multiple users are required to access the database at the same time, that is called as concurrency. For an example, अगर university का data है and 3 different professors want to access their faculty data or students data, that is much possible which happens in the university, right? So in such cases, what problems can occur? इस example को लेके सोचोगे तो थोड़ा better understanding आपकी हो जाएगी. Let's understand the first problem, which is lost update problem. This problem indicates that if two transactions, which is T1 and T2, both read the same data and update it, then effect of the first update will be overwritten by the second update. So if it's reading the same data, read X first, read X over here, it will update the X equals 75 and this will update X equals to 50. This will override this update. However, this should have got finished first and ये बाद में होना चाहिए था. So transaction T2 must not update the data until the transaction T1 has been completed and can commit that data item X. So in such scenarios, we lose the updated item. So this is called as lost update problem. Second is dirty read problem. So let's say X की value is 100. The dirty read arises when one transaction updates some item and then fails due to some reason. This updated item is retrieved by another transaction before it is changed back to the original value. As we see over here in the transaction T1, it is reading X. However, the update has been happened over here. Update X equals to 50. So it will get the value of X as 50, but due to some reason it fails over here and it rolls back to 100. However, this has executed already the X value as 50. So transaction T1 must not read the data item until the transaction T2 can commit data item. This is another problem of the concurrency. Third one, incorrect retrieval problem. So in this case, let's say the A is 200, B is 250 and C is 150. This is transaction T1, this is T2 and this is, let's say, the given amount of time. Okay. The inconsistent retrieval problem arises when one transaction retrieves the data to use in some operation, but before it can use this data, another transaction updates that data and commits. Does that happen? In most possibilities, that can happen. It will read the A's value, which is 200, create a variable sum equals 200, read B's value, which is 250. Sum equals sum plus 250, which means 200 plus 250 will give you 450 as the sum value. Over here it is going to read the C's value, which is 150. Sum equals sum plus 100, which is 450 plus 100, it will give you 550. However, over here it is already reading the C's value before this transaction has been committed. So this will get the value as 150 and it will update the C as 150. 150 minus 50, it will give you 100. It will read A's value, update the A's value as 200 plus 50 and gives the 250 and can commit. So over here, as we see, transaction T2 and T1 both have different inconsistent values. Through this change will be hidden from first transaction and it will continue to use the previous retrieved data. This problem is also known as inconsistent analysis problem. How to avoid a transaction T2 must not read or update data item X until the transaction T1 can commit the data item X. Let's see the next topic, lock. Now what is a lock? A lock is a variable associated with the data item to control concurrent access to that data item. We can put a lock on that variable which one user is using at a certain point until all the commit operation is done and then the next user can use it. So this is the database. If this user is accessing a given amount of columns or table, then we will lock it with the lock variable so the other user cannot access that same data for a given period of time. So now let's understand the lock-based protocol. Data items can be locked in two modes. First is shared mode. When we take this lock, we can just read the item but cannot write. So we can access it, we can see it but cannot edit, which means cannot write. Exclusive mode. When we take this lock, we can read as well as write the item. So let's understand the lock compatibility metrics over here. There is a transaction T1 and this is for T2 in the graph. Shared lock, exclusive lock. Shared lock over here, exclusive lock over here. In transaction T1 and T2, both have shared lock. Yes, it is compatible. If one of them has an exclusive lock and one shared lock, not compatible. Over here, if one has exclusive lock and one has shared lock, not compatible. One have exclusive lock and other one also has exclusive lock, still not compatible. So it is compatible only in one scenario when it is a shared lock and shared lock in both the T1 and T2 transaction. A transaction may be granted a lock on an item if the requested lock is compatible with the locks already held on the item by other transaction. So when these both transactions are going on and there is already a shared lock on T1 and T2 also has a shared lock, then the access will be given. However, if it is trying to apply the exclusive lock and the shared lock is already there, then it is not compatible. If a lock cannot be granted, the requesting transaction is made to wait till all compatible locks held by other transaction have been released. The lock is then granted. Any number of transactions can hold shared locks on an item, but if any transaction holds an exclusive on the item, no other transaction can hold any lock on that item. अगर exclusive lock लगा दिया मतलब ये तो final lock है, इसके ऊपर और कोई lock लग नहीं सकता है, और shared lock के ऊपर you can still put an exclusive lock. So I hope you're getting this. This locking protocol divides the transaction execution phase into three parts. Let's understand part by part. When transaction starts executing, it creates a list of data items on which they need locks and requests the system for all the locks it needs. So basically this is the lock acquisition phase. where the transaction acquires all the locks and no other lock is required, transaction keeps executing its operation. Transaction execution phase. As soon as the transaction releases its first lock, the third phase starts. In this phase, a transaction cannot demand for any lock but only releases the acquired lock, which is lock releasing phase. Transaction begins over here and ends over here. So what are the three phases? Lock acquisition phase, transaction execution phase, and lock releasing phase. Two-phase locking protocol. First is growing phase and second is shrinking phase. In the growing phase, a transaction obtains a lock but cannot release any lock. When a transaction takes the final lock, it is called the lock point. Shrinking phase. In this phase, transaction can release the locks but cannot obtain any lock. The transaction enters the shrinking phase as soon as it releases the first lock after crossing the lock point. So in the starting, we can say it's a growing phase as we are acquiring the locks, and the last one would be the shrinking phase as we are releasing the locks. So strict two-phase locking protocol versus rigorous two-phase locking protocol, let's understand the difference between them. In the strict two-phase locking protocol, a transaction may release all the shared locks after the lock point has been reached, which means lock point means the final lock, but it cannot release any of the exclusive locks until the transaction can commit or abort. It ensures that if data is being modified by one transaction, then the other transaction cannot read it until the first transaction has been committed. ये बहुत important है because इसी problem को solve करने के लिए we are putting the locking protocol. This protocol solves the dirty read problem. Rigorous two-phase locking protocol, a transaction is not allowed to release any lock, either shared or exclusive, until it commits. This means that until the transaction commits, the other transaction cannot acquire even a shared lock on a data item on which the uncommitted transaction has a shared lock. Even जिसके पास shared lock है, वो भी कोई lock acquire नहीं कर पाएंगे. That is rigorous two-phase locking protocol. The next one is timestamp based protocol. This protocol uses either the system time or the logical counter to be used as a timestamp. For an example, if I am teaching you right now, I have some time going on in my system, that is a timestamp. The website also takes a timestamp that at what time you have opened or reached the website. Every transaction has a timestamp associated with it, and the ordering is determined by the age of the transaction. Age of the transaction means कौन सा transaction पहले आया, कौन सा transaction बाद में. A transaction T1 is created at 02 clock time would be older than all other transactions which come after it. For an example, any transaction T2 entering in the system at 04 is 2 seconds younger than the transaction T1, and priority is given obviously to the old one. In addition, every data item is given the latest read and write stamp as well. This lets the system know when last read and write operation was made on the data item कि last edit कब हुआ था या last read कब हुआ था. This is the responsibility of the protocol system that the conflicting pair of tasks should be executed according to the timestamp values of the transactions. Because यहाँ पे कोई mishap या mix होने का सवाल ही नहीं उठता है, as the timestamp according to the seconds or milliseconds will always differ. Timestamp of a transaction Ti is denoted by TS or TI like that. Read timestamp of the data item X is denoted by R timestamp with the X, which is the data element. Write timestamp data item X is denoted by W timestamp. Now, timestamp ordering protocol. This is the responsibility of the protocol system that the conflicting pair of tasks should be executed according to the timestamp values of the transaction. We have already established that कि time के according उसको priority दी जाएगी. Now we have already seen how it is denoted as. Timestamp ordering protocol works as follows. If transaction Ti issued a read X operation, if timestamp of the Ti instruction is less than the write stamp of the X, operation is rejected. If timestamp of the instruction is greater than equal to the write stamp of the X, then operation will get executed. Again, in the same manner, we will see the read operation also. If timestamp of I instruction is less than the R stamp, less than hoga, again operation rejected. Again over here, if timestamp of the I instruction is less than the timestamp X, then operation rejected and it will also get rolled back. Otherwise, the operation will get executed in such cases. Let's understand the next topic, which is our last topic for the day, is called as deadlock. Consider the following two transactions, which is T1 and T2. Lock X has happened and then write A operation occurred. Then T2 operation starts. Lock will be granted for B. Over here lock is granted for A, so no problem. Lock X, write A. It is still waiting for A to release, so this operation is still on hold. Now over here we are waiting for B to release and still this operation becomes hold. So a deadlock is a situation in which two or more transactions are waiting for one another to give up the locks. In such cases it will be a deadlock situation because there is no way out. Let's see this with an example over here. A transaction A over here is waiting for transaction B and C. B and C. So that's why we have drawn the edges over here and edges over here. Transaction B is waiting actually for transaction D over here. This is wait for graph, has no cycle yet, so there is no deadlock state. Now suppose that a transaction D is requesting an item held by C. Then the edge from D to C is added to the wait graph. Now this graph contains the entire cycle, as we can see. It means that the transaction B, D and C are deadlock, because from B the arrow is going to D, from D the edge is going to C, and from C the edge is going to B. Now this is a deadlock situation. Now how do we do the deadlock recovery? When a deadlock is detected, the system must recover from the deadlock. The most common solution is to roll back one or more transaction to break the deadlock. Choosing which transaction to abort is known as victim selection, because wo transaction victim banne wala hai to roll back. In this wait for graph transaction, B, D and C are deadlocked. As we can see, B, D and C are deadlocked. In order to remove the deadlock, one of the transaction out of these three, B, D or C transaction, must be rolled back. We should roll back those transactions that will incur the minimum cost. Minimum cost means minimum amount of time it will take to roll back. When a deadlock is detected, the choice of which transaction to abort can be made using following criteria. The transaction which have the fewest locks, the transaction that has done the least work, and the transaction that is farthest from the completion. On basis of this three conditions, we can choose the victim to abort the transaction or roll back. What is the prevention to deadlock? Our protocol ensures that the system will never enter a deadlock state. Some prevention strategies which we can use that require each transaction locks all its data item before it begins the execution, which means the pre-declaration. Second strategy is impose the partial ordering of all data items and require the transaction can lock data items only in that order specified by the partial ordering system. Following schemes use transaction timestamps for the sake of deadlock prevention alone. So first one is wait die scheme, non-preemptive, which means you cannot preempt it. If an older transaction is requesting, which means the transaction which has come first, a resource which is held by younger transaction, जो बाद में आया है, then older transaction is allowed to wait for it till it is available. If a younger transaction is requesting, vice versa, for a resource which is held by the older transaction, then younger transaction is actually killed. Now, second is wound wait scheme. Now, this is preemptive. If an older transaction is requesting a resource which is held by the younger transaction, then older transaction forces younger transaction to kill the transaction and release the resource. If a younger transaction is requesting for the resource which is held by the older transaction, then younger transaction is allowed to wait till the order of the transaction will releases it. If older needs some resource from the younger, what happens in the wait die situation? Older waits, but however in the wound wait situation, the Y will be killed. In this case, if younger needs a resource held by the older, younger dies. Over here, younger waits. So I hope both the prevention scheme is clear with this table. Following schemes use transaction timestamps for the sake of deadlock prevention alone. So timestamps come very handy to prevent the deadlock. Timeout based schemes, a transaction waits for a lock only for a specified amount of time. After that time, the wait time is out and the transaction is rolled back. So deadlocks never get occurred. Simple to implement but difficult to determine good value of timeout interval. So some timeout is given for a certain period of time to a particular lock. This can also actually prevent the deadlock situation. So I hope this unit 7 was actually clear to you. If you guys have any questions, please do list them down in the comment section below. I will try my best to answer all of them. Please also go through all these questions. These are the majorly asked questions according to the university and previous year's paper. These are important IMP questions. Please solve them, note them down. You will not have a problem, I'm very sure, in this unit then. If you have understood this unit, then please give a like to this video. Also share it with your friends. Do subscribe my channel if you haven't done it yet. And I will see you in the next unit, which is unit 8. Bye-bye.